Okay, in this example, we are going to look at an example of a parallel RLC circuit. The circuit we have has a resistance of 15 ohms connected in parallel with a coil that has a resistance of 10 ohms and an XL of 30 ohms. Our supply voltage is 240 volts at 60 hertz. What we want to find for this circuit is the current in each branch, the total circuit current, and all power values for the circuit. Pause the recording at this point and draw out the triangles you would use to help solve this problem. Okay. This is what your drawing should look like with the triangles drawn to help us solve this circuit. We have a set of triangles for the circuit, a set of triangles for the coil, and a set of triangles for the resistor. If we are looking for the current in each branch, we need to use the current triangles. Now, for the resistor, the resistance of that resistive branch is 15 ohms. That is the total resistance or impedance of that circuit. So to find the current in that resistive branch, I equals E over R. And that just means I take the resistance, the voltage of 240 volts divided by that 15 ohm resistance, which gives me a current for the resistor of 16 amps. And that 16 amps I can put right here on my resistor triangle. One thing to keep in mind is that because the resistor has a value of 15 ohms, and that is the impedance of that resistor, then there is no inductive reactance, and the total impedance is the same as the horizontal or resistive part of that resistor, and it makes every triangle we have for the resistor just a basic flat line. So for this resistive branch, the current through that branch is 16 amps. For the coil, we have some inductive reactance and some resistance. So those values I have put on my impedance triangle, and what I need to find in order to find the current through the coil branch is I need to find the total impedance of the coil. So I need to use Pythagoras' theorem here and take the value of R squared and XL squared to find the total impedance of the circuit. The formula that I use is this formula here. And if I take 30 squared plus 10 squared and then take the square root of that to find the total impedance, my impedance comes out to 31.62 ohms. Okay. That is the total impedance of the coil in this circuit, and to find the current through that coil, I simply again take the voltage across the coil, which is 240 volts, divided by the impedance of the coil to give me the current through that coil. 240 volts divided by 31.62 ohms should give me a current through the coil of 7.59 amps. So I now have the current through the resistive branch of the circuit and the current through the coil branch of the circuit. If the next thing that we were looking for is the total circuit current, I need to combine the values from these two triangles to give me the total circuit current. The problem that I have is these two currents are happening at different angles. One is happening right on the horizontal, the resistive current. One is happening at an angle of some kind because the current through the coil has a resistive component and an inductive component. And I need to find both of those values. The easiest way to do that is to go back to my impedance triangle and find the power factor for my impedance triangle. The power factor for any triangle for the coil is the same. So if I know the power factor from the impedance triangle, I can use that power factor for any other triangle for the coil. And power factor always relates to the horizontal and the hypotenuse. So the power factor for the coil would equal 10 divided by 31.62, which is 0.316. Okay, with that power factor, I can simply put that same power factor on my current triangle for my coil. And now I can find the other two sides of the current triangle for the coil. The horizontal side, I can always get from multiplying the total coil current by the power factor. So 7.59 amps times 0.316 will give me the resistive current of the coil. 7.59 times 0.316 is 2.4 amps. Now to find the reactive current of the coil, I simply again use Pythagoras' theorem. The hypotenuse squared minus the resistive side squared will give me the value for my inductive current of this coil, and that current should come out to 7.2 amps. Now I have all three sides of my current triangle for the coil. I know the total current for the resistor. I can now complete the current triangle for the entire circuit. And current in parallel circuits adds up. So I can simply add similar values from my current triangles for each load to give me the total current in the circuit. I have 16 amps of resistive current on the horizontal for the resistor, 2.4 amps of resistive current from my coil. So the total, IR total, equals 16 plus 2.4, or 18.4 amps. The inductive current of my coil is the only inductive current I have in the circuit. The coil is the only thing that has inductive current, so that inductive current can come right up to my circuit current triangle as well. So my 7.2 amps goes right here. And now the current total for the circuit is simply the vector sum of the resistive current and inductive current. C squared again equals A squared plus B squared. So my hypotenuse will equal the square root of 18.4 squared plus 7.2 squared. And that number should be 19.76 amps. Okay, so we have found the current in each branch of the circuit and the total current for the circuit. The last thing we were asked to find is all power values for the circuit. To find the power values for my circuit, all I need to do is take the current triangle and multiply any side of that current triangle by my circuit voltage. So multiply by 240 volts. Any side of this current triangle multiplied by 240 will give me the same side of my power triangle. So the total watts, the total power in watts for my power triangle would be 18.4 amps, the resistive current, the resistive current times my voltage, which comes out to 240 times 18.4, should be 4,416 watts. So the total power of the circuit is on the horizontal. The reactive power, or Q, is on the vertical. 7.2 amps, the vertical side of my current triangle, times the voltage, times 240 volts, should give me the reactive power, which should come out to 1,728 bars, approximately. If you round off these numbers slightly in your calculation, it will change the numbers you have on the power triangle, but they should be fairly close to the values I have here. Our last value is apparent power. S is our total apparent power, which is the total voltage times the total current of the circuit. So 19.76 amps times 240 volts should give me the total apparent power, which should be 4,742 volt amps. And that gives us the power triangle values for this circuit. I could find the power values for the coil the same way. Take any side of my current triangle for the coil times the system voltage will give me the volt amps, the watts, and the bars for that coil. And the same thing for the resistor. I only have resistive current in that resistor, but this 16 amps times 240 volts should give me the total true power for that coil. And I could find the only power value I have for the resistor, which would be the watts of that resistor. So this is a way to do a parallel RLC circuit. Hopefully this will help you as you do more examples. That's good for now.